Lee here. I just wanted to do a quick video showing the exchange rate import routine. Now, we discussed earlier about how you can take an IDO, and the IDO, which would normally be mapped to a table or tables, for instance, can be unbound, and effectively here we've got a table that the IDO is mapped to, but all we've done is we've picked the first table off the list because all of the properties themselves are unbound. They're not bound to columns, they don't exist anywhere in our SQL database, they're certainly not persisted anywhere. What we've got instead is when we read these table records, we go out to a custom load method, and the custom load method, this type is hand coded. You can also have stored procedures which return result sets, but here we've got a hand coded custom load method which returns and accepts just a message ID to allow us to pass error messages back should we have any problems, and then it returns the exchange rate properties, rate, date, currency code, exchange rate. So I've got an IDO which has got no SQL table, it's got no database associated with it, yet somehow what we can do is we can get this IDO to return records. So if I just reopen my exchange rates, so this IDO with no tables, no data, no anything is returning records and presenting them. Where's it getting the data from? Well, the European Central Bank, if we go back to the main website and just have a look at the statistics and exchange rates, are kind enough to publish exchange rates which can be picked up by programs and programmers and incorporated into data. Now this is just one data source, there are others like XE and Oanda. The Free European Central Bank uses a very limited range of currencies and just provides a simple central spot rate. You could do some calculations based off that, but if you really want more currencies you probably want to look at another data feed. However, for this example it's perfectly good. So what the European Central Bank has is an XML file, a daily XML file that we can pick up with just this URL, and it's going to give us the exchange rates for the current date. And if we look closely, we see the Australian dollar 15916, 20th of January is the rate that's published in here. There we go, AUD 15916. We've also got BGN, there we are, 19558. So it's the same data, it's just presented in Mongoose. So how is Mongoose turning this into an IDO result set? In our IDOs, what we've done is we've taken a custom assembly, and a custom assembly is just a DLL file that we can take and import into Mongoose. And the custom assembly we attach to our IDO, and we also specify a class within that custom assembly that is then used to communicate with this IDO, and we can do several things once we've done that. Now the class itself is fairly simple, and the project itself is not too difficult to create. What we do is we take the Mongoose portal documentation, and Mongoose portal documentation is available on mongoose.infor.com. In the Learn section, we've got the documentation for Mongoose 9.2, and the one we're interested in is the IDO Development Guide. Now, if I just download a copy of that, then this has a number of sections in it, all of which are useful, but the one that we're interested in is creating a IDO.NET class library. And we've got examples here of how to do get property info and so on and so forth. So there we are, extension classes. So we've got here instructions on how to create an IDO extension class project, and it takes us through here and importing the DLLs and assigning the assembly info. Now this is in Visual Basic, but it's easy enough to take these examples and convert them to C# if that's what you prefer to work with. So here we have the exchange rates extension class assembly, and in here we've got an exchange rate class which extends extension class base. There's many things we can do with this, but what we've done in this case is we've implemented a load from ACB method which accepts and will pass back an information bar message and returns a data table, effectively a result set. And this is the same as the custom method signature here. So we've got ECB exchange rates class. We've got the load from ECB method, which is a custom load method, so it returns a data table or result set, and it accepts as an input parameter the message as basically an input and output parameter, and also special type message which allows it to do some extra diagnostic things, and then it returns rate, date, currency code and exchange rate. So effectively what we're looking to do in our data table is return a rate, date, currency code and exchange rate. So we create those columns in our data table with the correct data types, ones that match the expected data types of these properties. And then all we do is we use a little bit of .NET code to go out, fetch our exchange rate XML file, and then we're just using, in this case it's link, to identify all of the cube elements where we have a time attribute, and it's just a single return on there. That's going to give us the date here. We just take that date, we parse it, we get a time out, and then we do the same for all of the ones where it has the attribute currency, and this gives us a result set of the currencies. Loop through those. So for every result we find where we've got a currency, we take the rate date, currency code and exchange rate from the XML file, and we add a row to our data table. We also, because the European Central Bank has all of these rates against the euro, and it's implied that the euro exists with an exchange rate of 1, we add that in manually. So again, we've got a hard-coded value here, not difficult to do. We're going to use the data table and turn it into a view temporarily, just so that we can sort by rate date and currency code. That way it just makes sure it presents it in what is a better human readable format, as opposed to the XML file that we see on the ECB website. Now we can capture any errors, we can throw any errors back again if we need to. In this case I'm just capturing the errors, and if there is a problem it's going to log that into my IDEO runtime, which you see here, and it's also going to pass that message back into the load method, so we can then pick that up and interrogate it. Now if I clear my IDEO runtime log, and if I go into the exchange rates and do a refresh, it's going to go off to the ECB, it's going to read that XML file, and we see in here that it's adding all of these. And this is because I've been able to add some diagnostic information into my custom assembly class. So should anything go wrong, I can then see exactly what's doing it. So it's easy enough for me to write out log a user message, message type is udefined 0, adding time, currency, rate, and that's how this gets into the log. So you can do some quite interesting diagnostic things in here. And once we've got all of that put together, that result set comes back, it gets returned, and the last piece of the puzzle is, because we're loading our exchange rate using a custom load method, we just need to make sure that when we design our form, we specify this form is being loaded with a custom load method. In this case it's the load from ECB custom load method, which is now implemented in our IDEO extension class, and this gives us an opportunity to pass through message parameters. In this case, there are no message parameters, we're just listing them out. However, if in order to return a result set you needed to pass through some key fields, some filter criteria, something else, this is your opportunity to do this, and that can be passed in from a previous form, which can pass through form variables or something else. So we have plenty of options there. And that's really how the exchange rate function is nailed together, so that we can present data in Mongoose that doesn't actually exist in Mongoose. It could be existing in a web service, an XML, an external file, or anywhere else. Okay, so thank you for watching, and that's the end of that.